Today we're going to talk about graphs of functions. So let's compare a few scenarios. So in this first picture I have some zipliners, but these zipliners are like at the Fremont Experience in Las Vegas, where they're going straight across, not going up, not going down, just going across the street and like looking down below. In this other picture, the upper right, I have two people ziplining, but this time it looks like they're coming down a hill or a mountain and along some water, right? But they're going from a high point down to a lower point. And then this last picture over at the bottom, I have a guy playing basketball, and you can see when he's throwing that basket into the hoop, he's going to throw the ball up and then it's going to come down and hopefully go through the net. So what I want to do is just translate this into math, right? And look at this as a graph that we could put on an XY coordinate system. So what would that look like? If I put in an XY coordinate system, it looks like however high these people are, let's say they're 6 feet high, they're going to stay 6 feet high as they go across wherever they're going, right? So it's going to be the same all the way across. What that looks like as a function would be y equals b. I want you to get used to the idea too that y and f of x are going to be used interchangeably. So you'll see me do it, you'll see the homework do it as well, that sometimes we write y equals, sometimes we write f of x equals, but it's exactly the same thing. Again, why is that? Remember when we talk about putting points on, we say x, y, so y is the second value. And we also say when we do f of x, we're plugging x in to get the second value, which is y, so they're very interchangeable here. So again, just showing you that what's that going to look like? Anything that's y equals b would look like a horizontal line. Right. So let's go back to the slant. If there's a slant, then that's no longer y equals b, right? There's a slant to it. So if I wanted to draw this, let's just pick some numbers and draw. Say I have like this, I can see this line that is slanted. Now slants can go down, slants can go up. This one's going down. I'll do both today. This kind of equation, not really equation, more like a function, has this look of y equals mx plus b, or f of x equals mx plus b, and we will have a whole section dedicated to lines, right? So we're not going to worry about the m and the b for now. For now, what I want you to know is that when I have x and it's only to the power 1, it's going to produce a line for me. And we'll just plot some points, we'll plug some numbers in, and it'll give me what the graph looks like. So some of them will go up, some of them will go down, but in either scenario, it's going to be this nice line that we're going to draw. And then this last situation I had, which was the basketball player, where he's shooting the basket, it's going up, and then it's coming back down. This kind of scenario, we call this a quadratic, and it is going to be x squared. So let me show you what that looks like. So first I just want to show you the graph that here the ball goes up and then it goes down. This is the function, so this is much bigger, but what I think will really help for you to identify when is that going to happen is x squared. So I said if it's just an x, y equals mx plus b, that's a line. But if it's x squared, whether it has to be x or c, we'll worry about that later too, but anything x squared is going to have this kind of U shape, so it's either going to go up or down. And again, we'll get into that more later. This is just our little preview. All right, so let's go back and let's start with the easiest thing first, which was the horizontal line. So I said, let's graph y equals 3. So what this tells me is I go to the y-axis and I find the 3, and then I just draw a horizontal line through it. No reason to plug any numbers in. We just recognize what we have, and then we go and graph it. So here's our first one, y equals 3, and I said let's just do one more, which is y equals -2. What we're noticing is there's no x, right? X would say something else is going to happen, but without an x, I know it's going to be this nice horizontal line that goes through -2. So if we get something bigger, something with a slant, something where I have my y equals mx plus b scenario, I'm going to have a line, won't be horizontal, but what I'm going to need to do is find 2 points so I can draw the line. Let me tell you what I think is easy. I think it's really easy and helpful if you plug in 0. 0 usually gives us a nice number to start with, and then pick one other point. Now the other point you pick, a lot of times I pick 1, but every once in a while I pick something else. When is that other time? Maybe if there's a fraction or something and I don't want to deal with fractions, but we'll see that as we go. So let's start with y equals 2x minus 5. So the first thing I'm going to do is I'm going to plug in 0. Okay. So I put in 0. 2 times 0 is 0, minus 5 just gives me negative 5. So I have a point, 0, negative 5, I can graph. Now I can pick anything else, but I want to pick something that's going to fit on my graph nicely and I can see. So why don't we try plugging in 1? So here, if I plug in 1, I get 2 times 1 is 2, minus 5 gives me negative 3. So now if I plug in 1, I get negative 3. So I have 1, negative 3. There's my second point. 2 points, I can draw the line, right? You can see this one different from the one in our little preview. This one is going up. When I look at lines or graphs, I'm always looking left to right, so I can see this one's slanting up. Let's try another one. Here I have y equals negative 4x plus 3. Again, let's start by plugging in 0. I have negative 4 times 0 plus 3, which is 3. So here's my first point, 0, 3. For a second point, this time again, I'm going to plug in 1. So negative 4 times 1 is negative 4, plus 3 gives me negative 1. So I plugged in 1, I got negative 1 as my result. So we're at 1, negative 1, there's my second point. Just like last time, I want to connect the dots. Okay, so I have a line. You can see this was negative, it's going down, and again, we're going to have a whole section just about lines. So today we're just doing get a couple points, connect the dots. We're not going to worry about slope and intercepts if you're thinking any of that from classes you've had before. Not what we have to deal with today. So here's another one. It does have a fraction, so I have y equals 1/3 of x plus 2. I'm still going to plug in 0. Okay. 1/3 of 0 is 0, plus 2 gives me 2, so I have this nice point 0, 2 to start. For my next point though, I don't really want to plug in 1, because if I plug in 1, it's going to give me a fraction, and I don't want to try to graph a fraction. So what I'm going to do instead is I'm going to plug in the number 3, because I know 1/3 of 3 is 1. So you're just having to kind of think a little harder if a fraction comes up. So pick a number that's going to work out nicely for you. Now 1/3 of 3 is 1. 1 plus 2 is 3. So I have a point 3, 3. Right, now I can connect these two dots. So you do want to be strategic in the numbers you pick. You're not always going to use 0 and 1. I think 0 is always nice, but I think that sometimes you may have to pick another number for your second point. Right. I want to look at what the homework does. So let's flip over to My Lab of Mastering and see how you're going to do this. So here we are in My Lab of Mastering, and we're going to look at how to graph this. So here's my first one. It says y equals 5x. I'm going to click on the graph, and that's going to activate a toolbar. And the toolbar shows me some different shapes of kind of graphs I can draw. Now we know this is a line because it just has an x. So now I just want to click on the graph. So I want to click on a point I know is in there. So let's say if I put in 0, I'm going to get 0. Now I need to pick one more point. So I've talked about, let's plug in 1. Well, what's 1 times 5? It's 5. So I'm going to see, when I click over, I can see 1, 0 as the point. So I'm just going to go until it says 1, 5. And then I click, so I have my second point. So there's my 2 points. We said we need 2 points to draw a line, and then you check your answer, and it tells you, great job. That will be the same for whatever kind of line it is. So let's do one more. See that this one says 3x plus 6. So I know if I plug in 0, 3 times 0 is 0, plus 6 is 6. So let's hit the graph, pull our toolbar, and say we would like to start at 6. Now notice this one is scaled by 4, so it goes 4, 8, but you know, like you can go along there and it tells you what point you're on. I can see I'm at 0, 6. Now if I plug in 1, 3 times 1 is 3, plus 6 is 9, so this says, hey, if I plug in 1, I'm going to get 9. So we just pay attention to the coordinates that are underneath the graph. That'll really help you make sure you're in the right spot. So there's my 1, 9, and I check my answer. Right. So let's look at an application. So we're going to talk about medicine dosage. So for children weighing up to 88 pounds, the dosage of a medicine is 4 milligrams per pound. And what I looked up here is like penicillin, amoxicillin, right? These medicines the kids take when they're little. That definitely is based on weight to decide how much they should give. So they're giving 4 milligrams per pound. So what we're going to start with is we're going to come up with a function for the dosage. So x is going to be the number of pounds that the child weighs, and d of x is going to be the dosage. So our d of x is going to be 4 times the weight. So we know we want to do 4 times x, which is the weight. So easy to come up with this function. Okay. So now we're going to graph it. So we're going to graph the same way we did before, that we're going to start by plugging in 0, and I'm going to get 0. A little bit hard to see, but here is 0 right over here in the corner. Now, it may not be really helpful to plug in 1 because it's going to be too close and it's going to be hard for me to graph. So let's say, like, what if I plug in 10? 10 times 4 would be 40, which would put me here, and then I would be able to see this nice graph. Now, in the real world, I would want to use technology to make sure this is coming out the way it's supposed to. You guys can tell I'm not the best grapher. I would need like a ruler or something. So I would say if I was ever going to publish this or put this out, right, for sure, I would either put more points on to make it look pretty, or I would use like the technology we're using with the homework. Okay. Let's make this a little bit bigger. Let's go back to those graphs that we talked about, like the basketball player throwing a basket through the hoop, and that's called a quadratic function. So I told you already, you're going to know that that's happening because you're going to see an x squared in the function. So it'll be something like y equals ax squared plus bx plus c. Now the a, b, and c are just numbers. There's one rule. The rule is a can't be 0, right? If b is not there, that's okay. If c is not there, that's okay. I have to have some kind of x squared. Even if it's only x squared, it doesn't have to be anything more than that, but there has to be the x squared part in there. Then we have those two scenarios like we did with the lines, right? Where it was positive and had a increasing, like going up slant, and then when it was negative, it went down. So same thing's gonna happen with looking at this positive or negative. So when a is positive, the graph is gonna open up. And generally I say, well, it looks like a u. So x squared looks like a u. Then when a is negative, I'm just gonna flip that u upside down, right? So it's like an upside down u. So I want you to think about that. That's going to help you to graph. It's going to help you identify the graphs if the graphs were multiple choice. So x squared up and negative x squared down. So let's graph a few so you can really see what that looks like. So I'm starting with one that's positive. So before we ever graph it, we know it's going to have this look like a u. To make it easier, we're going to plug in a bunch of numbers because this is the first one we're doing. So I'm going to start with negative 2. So if I have negative 2 squared plus 2, remember if you're going to put this in your calculator, which I'm fine with, that you really want to use parentheses so that you get the right sign in your answer. So negative 2 squared is 4, 4 plus 2 is 6. So I have a point, negative 2, positive 6. Plug in negative 1. I have negative 1 squared plus 2. Well, negative 1 squared is 1, 1 plus 2 is 3. So I have negative 1, 3. Let's plug in 0. 0 squared plus 2 gives me 2. Then I have 1. So 1 squared plus 2, there's 3. And this 1 should really be a 2, so let's make that a 2. So I have 2 squared plus 2. 2 squared is 4, 4 plus 2 is 6, so I have 2, 6. Now this graph, this U that we form by connecting the dots, has something we would call symmetry. Symmetry just means I have like some mirrored part in there. So you see I have duplication. That duplication really helps you know like you did it right. That I can see I have 3 twice, I have 6 twice, so I see that nice little pretty graph that came out. And symmetry usually looks pretty to us. So this is my opening up, but we just used our points to draw it. Really what's going to happen when you're drawing is this point that's kind of like the bottom. This is called the vertex. So we want to make sure we're always graphing that vertex as we draw these quadratics, and then we just need a point on each side. One to the right, one to the left is usually a good idea. That way we just have that balance. We get those 2 points that are the same, and it helps us draw that U-shaped. Okay. So I'm going to try again. I just changed the numbers a little. So now I have negative 2x squared plus 5. So immediately that negative tells me this is going to go upside down. And I just gave the same numbers this time to plug in. So I have negative 2 times negative 2 squared plus 5. Be careful with all these negatives. Of course, grab your calculator if you want. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. So I have negative 2, negative 3 as my first point. I'm plugging in negative 1. So I have negative 2, negative 1 squared plus 5. Negative 1 squared is 1, times negative 2 is negative 2, plus 5. 5 minus 2 is positive 3. So I have negative 1, positive 3. Let's plug in 0. Negative 2, 0 squared, plus 5. 0 is the best number. Really is easy. I just get 5. So way up here. All right. What should happen now is I want to see this thing come back down. So let's try. I have negative 2. I have 1 squared plus 5. So negative 2 plus 5 is 3. That's good news. See how I've turned it around? It shows me I've gotten to my vertex already. Then I have negative 2 times positive 2 squared plus 5. 2 squared 4 times negative 2, negative 8. Negative 8 plus 5 is negative 3, which we're really not surprised about that because we got it earlier. So again, here's our, well, it's nicer when the computer draws it, but we'll go with it. So here's my nice little quadratic. Quadratics are also called parabolas, so sometimes you may hear that word or you might have heard it in the past, so I'll just go ahead and throw it in there just to say it. Maybe that's helpful. All right, so again, here we have this vertex and we have numbers to the right and left, and we want to get over to the homework so I can show you how to use that with the tool. All right. Sometimes these graphs are going to be more complicated because we really need to know, like, how are we going to find that vertex? So to help us out, I have a shortcut. So here's the shortcut. It says if I have this quadratic, ax squared plus bx plus c, we can find the vertex by finding negative b over 2a and then f of negative b over 2a. I promise, it's easier than it looks. So let's look here. I have, let's graph y equals negative 3x squared plus 12x minus 8. Now let me remind you, we're thinking about negative b over 2a, and that's all I want you to think about for now. Remember, I told you it was going to get easier. It has to be in order. So if you got a homework problem that wasn't written with x squared first, you want to rewrite it. So you always want to have it in order ABC. So I want to do negative b, so that's negative 12, over 2 times a, and a was negative 3. Save yourself time from the calculator and just go, well, that's negative 12 over negative 6. Then if you want to use your calculator, fine, but sometimes this part in the bottom, you really do need to group it together, so it's easier just multiply by 2. Negative 12 over negative 6 is 2. So 2 is my x-coordinate of my vertex. Now I need to plug that back in. So I'm going to have negative 3 times 2 squared plus 12 times 2 minus 8. So the negative b over 2a, that's the part that takes you a little bit of work, but not too bad. Then once you have it, you just plug it back in. And of course, you can grab your calculators to do that. So I have negative 3 times 2 squared plus 12 times 2 minus 8, and that gave me 4. So now I know, without a lot of work, that 2, 4 is going to be my vertex. Okay. So I'm going to go to the next slide so we can write some more. So here's my vertex 2, 4. Now I want you to think about this. This is negative. This is going to open upside down. So right here, this is 2, 4. So I want to pick a number to the right and a number to the left. So a number to the right of 2, think of bigger than 2. Let's plug in 3. And then a number to the left would be less than 2, so let's plug in 1. Now, if I'm doing it right, those numbers should be the same, right? When I plug in 3, And when I plug in 1, I should get the same answer. So let's see what we get. So I have negative 3 times 3 squared plus 12 times 3 minus 8. I'm going to grab my calculator. So I have negative 3 times 3 squared plus 12 times 3 and then minus 8. This gave me 1. Let's do the same thing with the number 1. I have negative 3 times 1 squared plus 12 times 1 minus 8. Okay, hopefully it's not a surprise we got 1 again. Okay, so now we have our 3 points. We have 2, 4, we have 3, 1, and we have 1, 1. Okay, so we're going to take those numbers and we're going to plot those on our graph. Right, and then just kind of connect the dots. Right, so a couple things we should be looking for. Was it positive or negative? So I know, does it go up or down? Where is the vertex? Use that negative b over 2a, and then grab 2 more points, because the homework is going to make you grab 2 more points if you're using the tool, and then we can graph. Okay. So let's jump over right now and look at that. I have x squared minus 3. Now on this one, if I try to do negative b over 2a, do you notice that the b would come from the x part and it's not there? X would be 0. So what does that tell me? It tells me that when I do negative b over 2a, I'm going to get 0. If I plug in 0, I get negative 3. So that says my vertex here is 0, negative 3. We'll keep talking it through. So here we are, we pick the graph, and this time I'm picking down here to say it's a quadratic. Hopefully you can see down there, it says a 3-point quadratic tool. So I'm going to click on that. And when I go over, I'm going to start with 0, negative 3. So I'm starting at that negative b over 2a part. Now I'm going to go 1 to the right, 1 to the left. If I plug in 1, 1 minus 3 gives me negative 2. Okay, same thing on the left. If I pick negative 1, negative 1 squared is 1, minus 3 is negative 2. So now I have 3 points, which is what it's going to require when you're using this graphing tool. Then you can check the answer. All right, this one I have 8t minus 4t squared. Remember I told you they might be out of order, so you have to really pay attention, and you would really want to rewrite this one first as negative 4t squared plus 8t. So let's take a look at that one for a minute. So I have 8t minus 4t squared. So I'm going to rewrite it. Negative 4t squared plus 8t. So when I do negative b over 2a, that's negative 8 over 2 times negative 4. This is negative 8 over negative 8. That gives me 1. Right, so that's my x coordinate. To get my y, I'm just going to plug that in. So I have 8 times 1 minus 4 times 1 squared. 8 minus 4 gives me 4. So this 1, 4, this is my vertex. This is kind of lucky. If I think 1 to the right, 1 to the left, 1 to the left is 0. So if I plug in 0, 0 minus 0 gives me 0. So that's a good point. That says if I plug in 2, I really hope 2 is also going to give me 0. So let's try. I have 8 times 2 minus 4 times 2 squared. This is 16. 2 squared is 4. 4 times 4 is 16. So I also get 0. So here are my points. I have 1, 4, 0, 0, 2, 0. Now I can go back and I can say, all right, I know what happens. I have my 1, 4 to start. I'm going to click on the graph. I'm going to say pick a parabola, and I'm going to start with 1, 4, and then I know at 0, 0 and at 2, 0. Again, it really helps to look at the numbers underneath where it's showing you what the coordinates are, especially when it isn't like 1, 2, 3 on the tick marks on the graph. Right, then we can check our answer, And again, it says, great job. So I have one less application for us. Here I have a rocket is launched from a platform 100 feet high. The height of the rocket after t seconds is h of t is negative 5t squared plus 40t plus 100. So I want to graph this. We know it's a quadratic because it's squared. It doesn't matter that it's t. X, t, whatever the variable is, it being squared says it's going to be a quadratic. Because it's negative, I know it's going down, so that's important. But there's this little difference now that we're at in applications, that t is really only going to be greater than or equal to 0. We don't have any negative time, so it's not going to go back forever. So let's just look at, if I were to plug in 0, I would get negative 5 times 0 squared plus 40 times 0 plus 100, which is 100. So what does this say? This tells me exactly what the problem said. They launched it from 100 feet high. So where is it starting? It's starting at 100 feet. So we're going to graph that. Then I would also like to know, well, really how high is it going to go? So that's where I need to do my negative b over 2a. So this is negative 40 over 2 times, let's write that a little better. This will be negative 40 over 2 times negative 5. Again, I just keep encouraging you, go ahead and reduce that denominator, like make it prettier. So 2 times negative 5 is negative 10. So this just gives me 4. So 4 seconds after its launch, it's reached its maximum height. So what is that maximum height? Well, let's plug in 4 to find out. So I have negative 5 times 4 squared plus 40 times 4 plus 100. So I have negative 5 times 4 squared plus 40 times 4 plus 100 is giving me 180. So this will be my maximum height is 180, and that happens after 4 seconds. Right. So let's graph that. So I said we have 4 180. So here's 4. Let's go way up here to 180. And we also said we started at 0, it was up to 100. Now remember we talked about that symmetry, that left and right, that should be the same. So look, if it took 4 seconds to get up to from 100 to 180, it's going to take 4 more seconds to get back to that same place. So do you see how it was 4 on the left, 4 on the right? I used that symmetry so I didn't have to plug in another number. Then I can connect the dots. Now here, as we're connecting the dots, it is going to hit the x-axis again. I didn't try to make it accurate. I don't know that 10's the right one. I also know that this is multiple choice on your homework, so you're just having to really use the vertex and that beginning point to decide how you're going to graph this function.